Okay, welcome back. This is going to be lesson number 2 on simultaneous equations. If you haven't watched the first one yet, then please go back and watch the introduction to simultaneous equations, because otherwise this might confuse you quite a bit. So last lesson we looked at examples like this, didn't we? So this was our working for them. And we thought, well, what's the difference between them? We've got one plum difference, so 40 difference, and then because we knew the weight of the plum, we could then find the weight of the orange. And we modelled it as well with cups of teas and cookies. Hopefully remember this. Well, if we try and do the same thing with this, well, the difference between this is 2 teas and 2 cookies. And the difference in price is going to be £4.30. This doesn't actually help us solve it. We've still got an equation with 2 things we don't know, 2 unknowns. So that's not going to do anything for us. So how could we come up and try and solve these? Well, if I double my order to try and get some of these the same, because the whole point of last lesson was we spotted which ones were the same and we decided whether we were going to add or subtract. Well, if we spot which ones we need to spot which ones we can make the same. Well, if I double my order here, so times by 2, that's going to add on another cup of tea. Very nicely drawn. And 2 more cookies. And it's not going to be £5.20 anymore, it's going to be £10.40. We're assuming there's no special offers. Hopefully you followed me okay on that. So can we see now that we've got 4 cups of tea and 4 cups of tea? So the only thing that's the difference in this price is the difference of cookies we've bought. We bought 4 and we bought 3. So the difference is 1 cookie, and the difference in price from £9.50 to £10.40 is 90 pence. So now we've found the value of a cookie, we can easily go back and find the value of the cup of tea. So let's do that. Well, we've got 90, 90, 90, so that's £2.70 for the 3 cookies. So if we took them 3 cookies off our order, we'd be doing £9.50. Take away £2.70, that's going to get us £7.50, £6.80. And that's going to be £6.80 for the 4 cups of tea. And then we've just got to divide by 4, haven't we, to get the solution for the cups of tea. So I'm just doing that on my calculator. I probably shouldn't need to, should I? But I'm doing it for the sake of the video being nice and smooth. So then a cup of tea, we would do £6.80 divided by 4, that would be £1.70. So then we would have our tea is £1.70. And there we go, we've gone and found out what the value of these are. So how about you having a go at that one? See which one would make sense to kind of multiply by a number to increase the amount we've got, which would then match up an amount of squares or pentagons, and then you can do your elimination. So I'm going to put the answer up in 3, 2, 1. I misclicked. So hopefully you got 6 and 7. So for what I would do for this one is, again, I would times this by 2, because that would get me another square and then 3 more pentagons. And it would change that to 50, wouldn't it? So I know I've got 2 squares in each, so the difference would be 2 pentagons, and the difference would be 12. So a pentagon is 6. Can you see how I'm even going a step further in the knowledge here, and I'm translating these pictures into algebra, putting P instead of pentagon, and I'm going to put S instead of square. So I can simplify this picture just into 2 lines of algebra. So then when we find that a pentagon is 6, well, we can say, well, 6, 6, 6, 6, that's 24. So then the two squares must be whatever makes it left to get to 38, and that would be 7 and 7, because we'd want to make 14 more. And you can just double check it for that one as well. And it doesn't matter that you've doubled it, because you've doubled absolutely everything, including the values, or the price in this case, it's still the exact same equation. So, let's go into some examples with algebra, which are more commonly seen. So what do you think we might do with this? I always like to, with simultaneous equations, label my equations. So that's equation 1, and that's equation 2. So I can say, well, I'm going to do equation 1 multiplied by 2. And that gets me 8x plus 4y equals to 52. And then I'm going to write equation 2 below it. Same side, subtract. Same sign, subtract. So 8x take away 6x is 2x. This would cancel to be 0. And 52 take away 44 is 8. So x equals to 4. Put a little box around that because that's one of our answers. And let's go and substitute that into any of them. I'm going to substitute it into the original number 1. Sub x equals 4 into 1. So we can see how this is kind of setting out to be nice and neat, and I don't have to be writing this equation out loads again. So 4 times 4 is 16. So then 2y equals to 10. Y equals to 5. So, I'm not with it today, am I? You'll go. You know the answers if you've just checked then, but see if you can get to them. So pause the video. 3, 2, 1. That's your answer. So, what I would have done on this, I'd have done equation 1 times by 3 this time, because I want to match the a's up. So 9a plus 12b equals to 66, and then I'm going to write equation 2 just below it. Same sign, subtract. This would cancel to be 0. We'd have 7b. And 66 take away 38 would be, well, take away 30 would be 36, take away another 8 would be 28. So then b equals to 4. Put a little box around that, that's one of our answers. And then I'm going to sub b equals to 4 into equation 1. You could, if you really want to, you could do 1 times 3 and you could label this equation 3, your third equation. And then if you want to sub it into equation 3, you could say that. But I'm going to sub it into 1 because it's the smallest numbers. It would work in any one, you can try it in all 3, if you really want to. So, 3a plus 16 equals to 22. So 3a equals to 6. And a equals to 2. Okay. We've got some examples here with different signs. So these two, let me check I'm on the right one. Yep, these two. So, if you want to have a go now, before I go through them, feel free. But I'm going to go through one and I'm going to ask you to go through the second one in a bit. So in this, I've got different signs, but I can still aim is to make everything have 2y. That's my aim, because I know if I times this top one by 2, equation 1, I'm going to get 8x plus 2y equals to 52. And then equation 2 would be 3x minus 2y equals to 25. Yes, we've not got exactly the same thing, but we've still got the 2 there, and we know if we have the same number but different signs, we add them together. So this would be 11x. This would cancel to 0. 2y plus minus 2y would be 0. And then when we add these together, we are going to get 77. So x equals to 7. Put a little box around that, that's one of our answers. And I'm going to substitute this into equation equation 1 again. It's not so it's just a coincidence I keep doing this equation 1. It's just because it's always the simplest equation. That's got negatives in. This one's just larger numbers, more room for mistakes. So 4 times 7 is 28, plus y is 26. So we want to take 28 from both sides. Y is going to be equal to minus 2. Let's double check that. Spot on. So, have a go at this one for me, please. So 3, 2, 1. You should get u equals to 10 and w equals to minus 4. I'm going to times this one by 2 this time. We don't always times by 2. You've seen one where we times by 3. But I'd have, so this would be equation 2 times by 2. This would be equation 1. So 4u minus 2w equals to 48. 3u minus 2w equals to 38. Same sign, subtract. So we would get u equals to 10, which is a nice easy, we don't have to do anything past that. And then when we go and substitute this back in, I would probably substitute this back into equation 2. So 20 minus w equals to 24. I need to take w to the other side by adding it, and then I'm going to take 24 from both sides. So there we go. I'm just going to pop these up with the answers in case you want to have a go at them, to just, if you didn't get that one right, you might want to just double check that you can get one of these right. Actually, no, do not do that. This is one I want to go through with us on this slide. So, sorry about confusing you there. This is our final skill. So this is our hardest skill with simultaneous equations in this sense. What do we think about this? Well, I can't multiply my p's to be anything to make it 5. I don't want to multiply by 0.5s. I don't want to multiply this by 2.5. That's going to get really messy. And I can't multiply my q's by anything to get from 2 to 3, apart from 1.5, and again, I don't want to do that. Well, what I can do is I can multiply both of them by a number to then them kind of match up. So just kind of pay attention to this. I think I want to get these, so my aim is to get 6q for both of them. Because I know 2q and 3q, I can make that up to 6q. I could have also aimed to get 10p, couldn't I? They'd both got me to the right answer. I just thought timesing by smaller numbers would be better to get to 6q. So I need to do equation 1 times by 2. It's going to be 4p plus 6q equals to 22. And I'm going to do equation 2 times by 3. So that's 15p plus 6q equals to 66. So you can see I've times all of this 1 by 3, all of this 1 by 2, and it's got me to what I wanted. I now have the same number of q's in these equations. Just like I've been doing before, I probably want to write the biggest one on top. So actually, I'm just going to write this below. I'm going to draw a bit of a dotted line there. Not done anything fancy there, I've just written that below because I know when I do my subtraction, because it's same sign, subtract, both positive 6s, I know I'm going to avoid negatives doing it like this. So 15p take away 4p is 11p. 66 take away 22 is 44. These cancel out to be 0. So p equals to 4. Well, I probably want to sub p into number 1. sub p equals to 4, I should say, into equation 1. So 2p is 8, plus 3q is 11. You might just be able to spot from this that q equals to 1. So there are our answers. So, final question for this video is, just have a go at this one, please. Okay, and 3, 2, 1. We've got our answers. So if you got that right, feel free to click off. If not, I'm going to go through it. I probably want to make these both to be 10y is my aim. You could have also made them 21x. Completely up to you. Both would work. So equation 1, equation 2. I'm going to do equation 1 times 5. That's going to get me 35x plus 10y equals to 300. And I'm going to do equation 2 times by 2. Don't want to have an equal sign there, I'd have a colon. That would be 6x plus 10y equals to 10. So I've already got the bigger one on top, so I don't need to mess about with changing the order of them. Same sign, subtract. So this is going to be 29x equals to 290. So x equals to 10. And then I'm going to sub x equals to 10 into probably, I'm going to do it into number 1. So x equals 10, that's 70, plus 2y equals to 60. Take away 70 from both sides. 2y equals minus 10. Y equals to minus 5. So that's all I want to do for this video. There'll be some questions linked to this sort of technique. Hopefully it's given you confidence to have a go, and always just message me if you need any help. Alright, cheers.